Welcome to Honors Geometry Lesson 2.1, where we talk about logical thinking beginning with inductive reasoning. And we're going to try to make you good thinkers before the end of this chapter is over with. And yes, you're going to feel like in this chapter that sometimes you are doing English instead of math. And I think I'm okay with that. So let's go ahead and look and see what inductive reasoning is. Alright. Go ahead and write this down as you pause, and I'll be right back. Alright, you get that copy down all right? Good. Alright, so remember, to prove a conjecture is false, you only need one counterexample. We'll see that in a minute. Right now, we're going to look for some patterns. Are you ready? Alright, identify the pattern. What's going on? That's right. It's increasing by 3. So the next three numbers are 18, 21, and 24. Good. Let's move on to the next one. 1, 2, 4, 8, 16. What's that pattern? That's right. It's doubling each time. 32, 64, and 128. Or you could say these are powers of 2. 2 to the first power, 2 to the 0 power, 2 to the first power, 2 to the second power. Oh yeah, absolutely. Let's go ahead and look at the next one. Alright, 6, 7, 14, 15, 30, 31. Well, I definitely see something going on here where it's doubling. And in between the doubling, what's going on? Looks like we're adding 1. So it looks like we're ready to double. 62, add 1, double. 126. Oh, I think you're pretty smart, don't you? Alright, the next one. What's going on here? That's right. It's going down by 7 each time. Absolutely. Whoa, -8, not -6, and -15. And I think that's the last one for this page. It is. Let's go on to the next. Set. Do you see it? What is it? Sure. Decreasing by 15 each time. Sure thing. This one might be a little bit harder to see. Got it? It's multiplying by 4 each time. So this would be 1280. And this would be 48 plus 320, 5,120, and 20,480. That one took me a little bit of work to get that in my head, multiplying like that. Alright? Oh, come on. I know I'm insulting your intelligence, aren't I? Yes, it's just increasing by 5 each time. Sure thing. Let me see if I can find something that might mess you up. This one, not going to mess you up. It's just increasing by 6 each time. Come on, Manning. Give us something that's got a little bit more meat to it than that. And that's the last one on that page. Alright, here you go. Here's something that you'll have a little bit more difficulty with. Alright. Do you see it? Okay, it was increasing by 5, then it increases by 10, then it increases by 15, then it increases by 20, then it increases by 25, then it increases by 30. And those increases are consecutive multiples of 5. That's actually what's going on there, consecutive multiples of 5. Alright? Let you think on that one for a minute. Sorry, that's all the time you get. How much does it increase right here? 3. Good. How much does it increase right here? 5. Excellent. How much does it increase right here? 7. And that's an increase of 9. So go ahead and increase by 11, 36. Increase by 13, 49. And increase by 15, 64. And that pattern actually does work, but that's not the real pattern. This is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, and 8 squared. Bet you didn't see that one coming. Yeah, maybe you did. You guys are pretty smart. Hey, I want this to go down here. Alright, let's look at the next one. Oh boy, JFM AM J, and the next one R J A S O N D. Of course. You know what? If you need me to explain that one tomorrow, go ahead and ask me. Oh, and this one, I want to do this one in class with you guys, because that one I really enjoy. So that's finding a pattern, making a conjecture, and then going on and making a conjecture is making the next statements there and what you think the next numbers or letters will be. Alright, let's move on. Proving conjectures are false. All birds can fly. Go ahead. Give me a counterexample. And all you need is one. How about if you're from New Zealand? Kiwi. How about if you're from Australia? Good. Emu. How about if you're from Africa? Excellent. And how about if you're from Antarctica, or possibly even the southern tip of South America, or the southern tip of South Africa? That's great. Yes, penguins. And there's a couple other examples that are extinct. Nobody can forget the dodo bird. Extinct now for, what, 500 years, or not quite, something like that. And, of course, my favorite extinct bird, the moa. You don't know what that is? Look it up. Every square is a rectangle. Okay? That is actually a true conjecture. You're not going to prove that one false, because every square has 4 right angles. That's the definition of a rectangle. It's got 4 right angles. The product of two numbers is never less than either of the two numbers. Product of two numbers is never less than either of the two numbers. Let's try 4 times 2. 8. Is that less than either of those? Nope, that doesn't work. That's not a counterexample. How about 4 times 0? That's 0. Is that less than either of those two? No. Alright, let's try 4 times -1. That's -4. Is that less than both of... Yay, there you go. There's your counterexample. Multiply 1 positive and 1 negative, and that's a counterexample. The sum of 5 and any positive integer is divisible by 5. So you know, like 5 plus 10 equals 15. 15 is not divide... Oh, bad example. That's not a counterexample. So pick something else. How about 5 and 6? 5 plus 6 is 11. Is 11 divisible by 5? No, not evenly. There's your counterexample, or possibly any other counterexample. The sum of a number and its absolute value is always 0. Like 6 plus the absolute value of 6. 6 plus 6 equals 0. No, it doesn't. There you go. There's a counterexample. All primes are odd. You're only going to come up with one counterexample. Remember, prime numbers are two numbers that have prime numbers are numbers that have exactly two factors. And the first prime number is 2. A whole number is divisible by 10 if its last digit is 0. 70. Yeah, that's divisible by 10. That's not a counterexample. In fact, you're never going to come up with a counterexample because this is actually a true conjecture. Can't come up with counterexample to prove it false. Alright? All roses are red. Come up with a counterexample. You can do it. The product of two integers is always even. Experiment around a little bit with that one, and you'll find out that you can prove it false. Okay, I expect you to come in with counterexamples for both of these in class tomorrow. I'll be asking questions about them. And don't forget to ask me about that one pattern where it was O, T, T, F, F, that one. Alright? Oh yeah, don't forget to ask me about the pencil pattern as well. I definitely want to go over the pencil pattern with you guys in class as well. Alright, so you've got a little bit of work to do. I've got a little bit of work to do. This will conclude Honors Geometry Lesson 2.1, Inductive Reasoning.